Assalamu alaikum. My name is Akil Ahmed, and I will be explaining our project Windmill Generator Circuit, its working, the role of each component, especially the LED, and finally discuss whether this is a real-world implementation or a simulation, along with possible improvements. To understand how AC power generated from a wind source can be converted into usable DC power, and how this power can be used to drive a simple load like an LED. The circuit represents a basic wind energy conversion system. The windmill is represented by an AC voltage source. The generated AC power is then rectified, filtered, stored temporarily, and finally used to power an LED. This helps us understand the fundamental stages of renewable energy power conditioning. The circuit starts with an AC voltage source. This AC source represents the alternating voltage produced by a wind turbine due to continuous rotation of its blades. Since wind speed varies, the voltage is not stable in real life, which is why power conditioning is required. Bridge rectifier. The four diodes that you see here form a full wave bridge rectifier. Its purpose is to convert AC voltage into pulsating DC. Regardless of the direction of the AC input, the output polarity remains the same. This is a very important stage because electronic components like LEDs and capacitors require DC power instead of the AC power. The load resistor represents a basic electrical load. It limits current, it simulates power consumption from the generator, it also helps in analyzing voltage levels in the circuit. And the conductor here is used for current smoothing. It resists sudden changes in current, it stores energy temporarily in a magnetic field which helps reduce ripple from the rectified DC signal. In real power systems, inductors are commonly used in filters and converters. Now here we have this blocking diode. This diode ensures one-way current flow. It prevents stored energy from flowing back toward the generator, which protects the rectifier and source from reverse discharge. This is especially important in renewable energy systems where input power is not constant or reliable. The switch here is used to demonstrate how connecting or disconnecting the load affects energy storage and LED operation. The switch is placed on the output side of the system near the capacitor and the LED. Its main purpose is to control how the stored energy is used and to demonstrate the charging and discharging behavior of the circuit. When the switch is open, the circuit operates normally. The rectified DC power flows through the inductor and the blocking diode, allowing the capacitor to charge. As the capacitor charges, it supplies voltage to the LED, causing it to turn on. This represents the normal condition where energy generated by the windmill is delivered to the load. However, when the switch is closed, it creates a direct discharge path. The stored energy in the capacitor is released quickly, which causes the voltage across the LED to drop. As a result, the LED turns off or becomes very dim. This shows how removing or bypassing the load affects the output of the system. Overall, the switch helps us visually understand how energy storage behaves under different conditions. In real wind energy systems, this function would be handled by electronic controllers or dumb loads instead of a manual switch. The capacitor here stores electrical energy and smooths the DC voltage. When voltage increases, the capacitor charges, and when voltage decreases, it discharges slowly, which reduces flickering and voltage drops. This capacitor represents the concept of energy storage similar to a battery in real systems. Now coming to the LED, which is the most visible part of the circuit, this LED acts as a visual indicator. It turns on when enough voltage is available, which shows that energy from the wind generator is successfully converted and delivered to the output. In this project, the LED does not represent a high power load. Instead, it demonstrates successful power flow and energy conversion. Now the question remains, is this a real system or just a simulation? Well, the project is primarily a simulation-based demonstration. The circuit shows the working principle of a wind energy system to give a basic idea. It is not designed to power real appliances. The component values are simplified for learning purposes. That's why the circuit may seem very basic because of the values and the output voltage value. However, the concept is real and similar stages are used in actual wind energy systems that rely on wind turbine AC generation. Given that, we can discuss the limitations of the current design because it's not that practical in real life industrial scale projects. It is just to give an idea like how the wind turbines work. Now the limitations are that it has a very low power output, it has no voltage regulation, and of course small capacitor for storage, which is not very efficient. The LED brightness depends heavily on input voltage, so the LED may flicker, and even dim at some certain instances. Also, there is no protection against overvoltage or fluctuations. But if this were to be developed further, keeping the practical application at the industrial level in mind, the following improvements could be made. We can replace the LED with a regulated DC load, add a voltage regulator for a stable output, and use a larger capacitor or battery for better energy storage. We can also implement a DC to DC converter for efficiency and improve filtering to reduce ripple. Also, before I suggested that there is no protection against overvoltage, so we can also add protection circuits for real world use. To conclude, this circuit successfully demonstrates how wind generated AC power can be converted into DC power and used to drive a simple load like an LED. Although the actual applications and working of a wind turbine generator at that actual scale is somewhat different than this, but the basic concepts are similar and almost the same. So, even though this is a conceptual and educational simulation, it clearly explains the core principles behind renewable energy systems, making it a strong foundation for more advanced designs. And that was our project. Thank you for watching.